Good morning, scholars. I hope that all is well with you so far. Today we are moving into topic number 7, which focuses on operations with integers and with signed numbers. So now we're going to be dealing with positive and negative numbers. This lines itself up with sections 1.2 and 1.3 of the algebra textbook. Again, for CP and below, this is part of your first unit. For honors, this is prerequisite knowledge that you would need to know before the start of the school year. So, with that being said, in math, you'll be working with real numbers, which all of them you can put on a number line. So far we've been dealing with exclusively positive numbers. Now we're going to branch that out a little bit and look at positive numbers, negative numbers, and zero. These three categories combined make up what are called integers. So if you look at the number line, you have 0, which serves as the dividing line. To the left of 0 are your negative numbers. To the right of 0 are your positive numbers. So with that, the first thing that we can do is to compare integers and to put them in order. So when we're comparing and ordering integers, first thing, a negative number is always less than a positive number. So that's right off the bat. Positive numbers get larger as you get farther away from 0. So the farther to the right you go, the numbers are getting larger. Negative numbers get smaller the farther away you get from 0. So as you go farther to the left, the numbers get smaller. So this helps when you're comparing numbers. Obviously, if you're comparing two positive numbers, 6, 13, you're looking for which of the two numbers has the bigger value, which in this case it would be 13. So 6 is less than 13. With example 1, you have -9, +2. Remember, a positive number is always bigger than a negative number. So -9 would be less than 2. Example 2, we're comparing -4 and -11. So now they're both negative. So when you have two negatives, you're looking for which number would be closer to 0. Which number would be closer to 0? Which, if you look at it from a number line perspective, -11 would be there, and -4 is right there, and -4 is closer to 0. So -4 is greater than -11. So for two negative numbers, you're looking for which one is closer to 0. Example 3, order the following numbers from least to greatest. So you have 0.3, 7/5, -1, -1.5, 0, and 1/4. So if you look at it in terms of a number line, since you're going from least to greatest, you start with the negative numbers first, negative numbers, then 0, and then your positive numbers. So for your negative numbers, you're going from what number is the smallest and then working your way up. So you have -1, -1.5. So -1.5 would go first, followed by -1. You have a 0, so we put the 0 in. Now we do our positive numbers, which we have 0.3, 7/5, and 1/4. So remember, 1/4 is the same thing as 0.25, and 7/5 is the same thing as 1.4. Just in case you need the calculator to do that, feel free to do that computation. So in order, this would be 1/4, followed by 0.3, and then finally 7/5. So those are your numbers in order from least to greatest. Those are your numbers in order from least to greatest. So Examples 4, 5, and 6 are here as additional practice. When I post these notes to Google Classroom, I will have the answers posted for 4, 5, and 6. So they are optional practice for you. Moving on. So integers create two new mathematical operations, opposite and absolute value. So the opposite of a number is the number on the other side of 0 on a number line. So case in point, the opposite of a positive number would be a negative number. So the opposite of 3 would be negative 3. And the opposite of positive 5 over 4 would be negative 5 over 4. So it does not matter if the number is a whole number, a fraction, or a decimal. The rules hold up no matter what. Also, the opposite of a negative number is a positive number. Opposite of negative would be positive. So if you have negative 3.7, the opposite would be positive 3.7. If you have negative 8, then the opposite would be positive 8. Now notice for positive numbers, I did not put a plus sign in front. You don't need to. If there's no sign in front of it, it is understood to be positive. So those are opposites. With absolute value is a number's distance from 0. How far is a number from 0? Key thing to keep in mind here, the absolute value of a number is always positive. The absolute value of a number is always positive. And in terms of notation, absolute value is given with the double bars. It looks like you have two just straight lines going up and down. So this would be known as the absolute value of A in symbols. So for problem 1, we're going to find the absolute value of 9. So in symbols, this would be 9 inside of double bars. So the absolute value of 9 is 9. 9 is 9 spaces away from 0. Example 2, negative 10.4. So we're looking for the absolute value of negative 10.4, which is 10.4. Again, the absolute value is just whatever the number was, but positive. Example 3, negative 12. So the absolute value of negative 12 is positive 12. It's 12 spaces away from 0. Lastly, example 4, negative 11 over 4. So the absolute value of negative 11 over 4 would be positive 11 over 4. So again, same number, just as its positive value. So opposites and absolute values do come up a lot as we navigate through algebra, especially when we get into exponents, square roots, and order of operations, which will be what we will tackle next time. However, now we delve into adding, subtracting, multiplying, and dividing integers. So there are definitely different situations depending on what you're being asked to do. So we're going to start with adding. Adding integers depends on whether you have the same sign or if you have different signs. Same signs, different signs. So if you are adding numbers with the same sign, that means 2 positives or 2 negatives. Add the numbers up, keep the sign. So add them up the way you normally would, keep the sign that it originally had. So 43 plus 16 They're both positive numbers, so simply add them up. 59, and you're done. So two positive numbers will stay positive. If you're adding two negative numbers, again, add the numbers up. So 17 plus 8 is 25. And since both of them were negative, both numbers were negative, the answer will be negative. Since both numbers were negative, the answer will be negative. So that's with the same sign. If the signs are different, then we follow a different rule. Now, we're going to subtract the two numbers. So for in example 3, you have 17 plus negative 3. So the 17 is positive, the 3 is negative. So since the signs are different, you're going to subtract the numbers. And then you keep the sign from the bigger number. So since 17 is bigger than 3, and 17 was positive, your answer would be a positive 14. Your answer would be a positive 14. So again, you subtract the numbers and you keep the sign from the bigger number. With example 4, you have negative 14 plus 9. 14 is negative, 9 is positive. So we do 14 minus 9, which is 5. And since 14 was the bigger number, your answer would be negative 5. Your answer would be negative 5. So the key thing with adding is you have to look to see, are the signs the same or are they different? If they're the same, there's one set of rules, but if they're different, there's another set of rules. So that's adding. Subtracting. So subtracting, you might have heard of the acronym of keep, change, change from your days in middle school, but subtracting integers means we follow the given procedure. Bring down the first number, change subtraction to addition, write the opposite of the second number, and then solve using the rules for addition. So I'm going to illustrate this using some basic math principles. So we're going to do 10 minus 8. Now, you don't need to do the keep, change, change rule here. 10 minus 8 is 2. But I'm illustrating it to show you that it does work. You keep the first number, change subtraction to addition. You take the opposite of the second number. So the opposite of positive 8 would be negative 8. Notice that I put the negative in parentheses. Now we follow the rules for addition. So the 10 is positive, the 8 is negative. So you would do 10 minus 8, which is 2. 10 was the bigger number, so your answer would be positive 2. So once again, I don't expect you to do keep, change, change for something like 10 minus 8. You shouldn't need to. That's a basic fundamental math concept. If you need to, though, that's fine. So now let's work some other examples. Example 5, 27 minus 32. So you keep the first number, change subtraction to addition, and you take the opposite of the second number, which would become negative 32. Then we solve using our adding rules. We have a positive number and a negative number, so that means we subtract. And since negative 32 is, since 32 is bigger and it's negative, your answer would be negative 5. Your answer would be negative 5. Moving forward, example 6, 2 minus negative 5. So keep the first number, change subtraction to addition, take the opposite of the second number, so the opposite of -5 is +5. And 2 plus 5 is relatively simple, 7. Example 7, -9 minus -1. Keep the first number, change subtraction to addition, take the opposite of the second number. The opposite of -1 is +1. So now we look at what we have. You have a negative plus a positive, so that means you subtract. 9 minus 1 is 8. 9 was the bigger number and it was negative, so your answer is -8. Then lastly, problem 8, 19 minus -3. Keep the first number, change subtraction to addition, take the opposite of the second number. The opposite of -3 is +3. 19 plus 3 gives you 22. 19 plus 3 gives you 22. So it looks like the only version that isn't up here is of a negative minus a positive. So let's do an example of that. -7 minus 2. -7 minus 2. So this is example 8A. So again, keep the first number, change subtraction to addition. The opposite of a +2 would be a -2. So you have a negative plus a negative, so add the two numbers up. 7 plus 2 is 9, and you keep the negative. So for the sake of completeness, now we at least have an example of the four main types. So that's subtracting integers. Subtracting integers embodies the keep, change procedure. Moving into multiplying and dividing. Multiplying and dividing. Very, very simple rules. You multiply or divide the way you normally would. However, if the numbers have the same sign, the answer is positive. If the numbers have different signs, the answer is negative. So, same sign when you're multiplying or dividing. This is where a lot of people get confused. Same sign, multiplying or dividing, the answer is positive. Same sign, different signs when you're multiplying or dividing, the answer is negative. So, gotta keep track of what's going on. So, example 9, you have +9 times -9. So that's a positive times a negative. So the answer is gonna be negative. Now all you have to do is just worry about multiplying. 9 times 9 is 81. That's it, problem's over. Example 10, -1/2 times 24. So that's a negative times a positive, so you know the answer is going to be negative. Now you do 1/2 times 24. So 1/2 times 24, make 24 a fraction. 1 times 24 is 24, 2 times 1 is 2, 24 divided by 2 is 12. So your answer is -12. Example 11, -36 divided by -3. So a negative divided by a negative is positive. So 36 divided by 3 would be 12. So 12 is fine. If you had put plus 12, that's okay too, although you should break the habit of putting the plus sign in front of the number. If there's no sign in front of a number, we know that it's positive. Last but not least, example 12, 120 divided by 10. So you have a positive divided by a positive. So the answer is positive. 120 divided by 10 is 12. So plus 12 or just 12. So multiplying and dividing is pretty simple. Multiply or divide the way you normally would. If the signs are the same, the answer is positive. If the signs are different, the answer is negative. All right. And then one more thing is evaluating expressions using integers. Evaluating expression when integers are involved. So if integers are involved, okay, you're still substituting in for the values for the variables, but now you have to use all the integer rules that we just went through. So let's start with example 13. X minus 5 when x is equal to negative 4. All right? So that means we take negative 4, plug it in for x. You get negative 4 minus 5. So it's a subtraction problem. We know it's subtraction because of the minus sign in between the two numbers. So keep the first number, change subtraction to addition. The opposite of positive 5 is negative 5. A positive plus a positive, so 4 plus 5 is 9. And you keep the negative sign. So that takes care of that. Example 14. Negative 3y plus 4 when y is equal to 2. Take 2, plug it in. So that gives you negative 3 times 2 plus 4. Again, working from left to right. Negative 3 times 2 is negative 6. Negative 6 plus 4 is negative 2. And then 15, last example, x divided by y plus 6 when x equals negative 30 and y equals negative 5. So if we plug in everything, that gives you negative 30 over negative 5 plus 6. So we first have to start by going top to bottom with the fraction here. Negative 30 divided by negative 5 is a positive 6. Negative divided by negative is positive. And then 6 plus 6 is 12. 6 plus 6 is 12. So again, when you're evaluating, same rules apply. Plug in the numbers, but then you follow your integer rules. You follow your integer rules. So other than that, just like with earlier, this problem set here is more so for your own individualized practice, which I'll post the answers when I post this notes page for you to see if you did them correctly. With that being said, that completes your notes and instruction for topic number 7. Adding, subtracting, multiplying, dividing integers. We put integers in order from least to greatest, and we compared them, did opposites, did absolute values. So after you finish reviewing this video, make sure you work on the topic 7 assignments, which are IXLs, and then complete your topic 7 Google mini quiz. So if you have questions, please feel free to reach out and to ask. Otherwise, have a great rest of your day, and I'll talk to you soon.